So you have a ladder leaning up against a wall. How far up the ladder can you climb safely? So the ladder AD has a length of 6 meters. The center of gravity of the ladder is at the point B, and AB is 2 meters. The person, of course, starts climbing up from A and right now has reached the point C. And we are asked to find the distance AC that he can safely climb up. WP is the weight of the person and WL is the weight of the ladder. The weights act vertically down. N1 is the normal force acting at the ground where the ladder touches the ground. N2 is the normal force acting where the ladder touches the wall. And by definition, normal forces are perpendicular to the surface. That's why N1 is perpendicular to the ground and N2 is perpendicular to the wall. F is the friction where the ladder touches the ground. And friction is opposite to the intended motion. Since the ladder could slip out, that's why the friction is towards the wall. And where the ladder touches the wall, there could be friction. And if so, that friction would have been vertically up the wall. But in this particular case, we are assuming that it's a smooth wall. And that means there is no friction at that point of contact D. The weight of the ladder is 20 kilograms. The weight of the person is 70 kilograms. The coefficient of friction, static friction in this case, because there is no motion, that is 0.3. So the coefficient of friction between the ladder and the ground is 0.3. So now, there are two conditions for static equilibrium. The first condition is that the net force must be equal to 0. The second condition, that the net torque must be 0. So now we're looking at the first condition, that the net force must be 0. When you look at the forces upwards, you have N1 as the only force acting upwards along the y-axis. And there are two forces, WL and WP, that act down along the negative y-axis. So the total up force N1 should be equal to the total down force WL plus WP. Now when we look at the x-axis, we have F1. I've called it F1 because there could have been an F2 here. Okay, so F1 acting along the positive x-axis must be equal to N2, which is acting along the negative x-axis. So there's F1 along the positive x-axis and N2 along the negative x-axis. Both must be equal. Now, the next condition is to show that the net torque is equal. Now for that, we could calculate the torque about any convenient point, but I'm going to pick the point of contact between the ladder and the ground as the point where I'm going to calculate the torque. Now why is that? Because in that case, the torque due to N1 and F both will become 0, because we're calculating the torque exactly about A, and that's the point about which these two forces are acting, which means the distance of these forces from A is 0. Remember, Torque is the force multiplied by the perpendicular distance from the point. Since the distance of N1 and F from A is 0, their torques are 0. That leaves N2. You can see N2 is counterclockwise. N2 is counterclockwise, and the torque would be N2 times, what's the perpendicular distance between that force and the point A? This is going to be the perpendicular distance, right? Because this is the force or line of action of the force. Here is the point. This is the perpendicular distance, which is the same as dg here. dg is the perpendicular distance. So the torque due to N2 is N2 times dg. That's counterclockwise. And then there are two clockwise torques. One is WP, and the torque due to that would be WP times AF, because this is the line of action of the force. This is the perpendicular distance. Another clockwise torque would be due to the weight of the ladder. The weight of the ladder is acting along this line. This is the perpendicular distance, so it would be the weight of the ladder multiplied by AE. So the second condition, we are again calculating the torques about the point A. There is one counterclockwise torque and two clockwise. So here are the clockwise ones. The weight of the ladder times AE plus weight of the person times AF is equal to N2 times dg. Now what is left is to calculate by substituting into these two conditions. Now we know that AE by AG is AB by AD. AE by AG, you see the ratio, AE by AG is equal to AB by AD. That's a case of similar triangles. So you see a small triangle here, ABE, and the bigger triangle ADG. The ratio of their sides are equal. So AE by AG is equal to AB by AD. When we do that, we'll be able to calculate the value of AE, and we will get it as 1 meter. Why? Because AG is 3, AB is 2, and AD is 6. So on the right side you get 2 by 6, which is 1 by 3, 1 by 3, and this 3 goes to the top, so it becomes 3 by 3. That's equal to 1 meter. So we get AE as 1 meter. Now friction we know is mu S times N1. Friction, that's the formula for friction. And N1 from the first condition is the weight of the ladder plus the weight of the person. Now you know, to get the weight you have to multiply the mass with the acceleration due to gravity. So I added the masses of the ladder and the person, 20 plus 70 multiplied by 9.8, that gives 882 newtons as the normal force. Now plug that value into this formula. Mu s is 0.3, N1 is 882, and you get 264.6 newtons as the force of friction. So 20 times 9.8 times 1. I'm applying it into this condition now, calculating the torque. 20 times 9.8 is the weight of the ladder, times AE is 1, plus the weight of the person. 70 times 9.8 times AF, which we do not know. We're trying to find AF. And from there we will be able to find AC, okay? Should be equal to, on the right side, N2 times dg. Now what's N2? N2 is the same as friction. So we already got friction is 264.6, so that's N2. Friction is 264.6, so that's N2 times 5.2. Now where did I get that 5.2 from? 5.2 is dg. You see, in the right angle triangle, this side is 3 meters, this is 6 meters. Surely this side is 6 squared minus 3 squared, and then take the square root of that. So that's what I've done. Square root 6 squared minus 3 squared gives 5.2. So when you do the calculations, 20 times 9.8 is 196. 70 times 9.8 is 686 times AF is on the right side. You get 1375.9. That gives AF as 1.72 meter. Of course, to do that, I had to take 196 to the right side, subtract it, and then I get 1.72 meter. So once you get AF, you got to find AC, which is easy because you take the ratio again, right? AF by AG is equal to AC by AD, just like before. And that gives AC as 1.72 divided by 3 times 6 is 3.44 meters. Because AF is 1.72, AG is 3, and AD is 6. So that gives 3.44 meters. That means this person can safely climb up to a distance of 3.44 meters. How could this distance have been increased? Yes, by increasing the friction, leaning the ladder even more vertically, although if you make it too much, it'll be dangerous. So you could do that. You could climb up a little bit more if you made it more vertical, but there is a limit. So this is how you work out the problem on safely climbing up a ladder.